Hey guys, I'm just going to go through an example with you guys. A lot of people ask questions today about the Khan activities, so I grabbed one that was a little more challenging and thought this would be a good one to show you. First, because there's a negative out in front of your sine or cosine function, and then second, because it is a cosine function. That was a question that a lot of people had. This is going to be my first time playing around with the annotation here on Khan Academy, so maybe bear with me. So first, what they start you with is a random sine function, and we want this to be a cosine function, so it's going to start up at its maximum value. And the funny thing is, this won't let this have the same x value. So, as you start playing around with it, you're trying to get it to be how you want, and sometimes it's a little bit of a hassle. So you notice you've got it goes up to 2. We don't want it to go up to 2. We want it to be here at 1, and like it does take a little bit of playing around with to get to look how you want. And then this is not our parent function either. The period on this guy is 4 pi, as you can see. So we want to squish this back here. And so now we've got our parent function here, y equals cosine of x. And the reason I did that is this is helpful to walk through how these different things affect what's going on step by step. Now, when we do this, we always do the multiplies first on our graph to get the changes that we're looking for. So I'll try to color code this as we go. So if I throw that 2 on here, y equals 2 cosine of x. That means your amplitude here is 2. And so let's make this have an amplitude of 2. So there's our function y equals 2 cosine of x. Now that negative out front, the negative, so y equals negative 2 cosine of x. This negative here does a reflection across the x-axis. I'm just going to do our little shorthand, r sub x. I'm going to try r sub x. So let's just take this guy and do that. So there is y equals negative 2 cosine of x, starting at the minimum value, amplitude of 2, and then the period is 2 pi here. The 1/6, so if we add the 1/6 into the equation, so y equals 1/6, the negative 2 cosine 1/6 x. So your period's determined by this number. So your period is 2 pi over that coefficient of x, which is 1/6. So our period on this guy is 12 pi. And so that's kind of hard to represent when your scale only goes from 4 pi to negative 4 pi. So we have to think about this. So right now my period is 4 pi. But I look at a quarter period here. A quarter period is pi. Here now, I have a quarter period that's 2 pi. Some period would be 4 of those would be 8 pi. And now I've got a quarter period that's 3 pi. 3 pi times 4 is 12 pi. So another way to look at this is you've got a half a period right here, and that's 6 pi. So there we go. Check. Our period is 12 pi. And then the last little bit is the -5. And if we throw the -5 in, this just means a vertical shift. That's usually the easy one to identify. It's just how do you represent that in the picture of down 5. So y equals negative 2 cosine 1/6 x. We've got that graph sitting right there. And then I just want to take it and shift it down 5. And the way, this is kind of a little trick on this, we're just going to shift both of these down 5 units. 2, 3, 4, 5. And now as we look at this, we see all the stuff we should see. You see the midline of our graph here is at negative 5. We see our period, and that's a little harder to see, but the period is from 0 to 3 pi times 4 is 12 pi. Check. And hopefully we click this and we get confetti.